There is a second approach which is quite similar, so see which one you feel more comfortable. And then again they say that the speed S1 is equal to 72, this speed is equal to 90, and then if you let the time here is equal to T1, T2, so the first constraint is about the time. T1 plus T2 is equal to 161 minutes. If you need, you may need to change the units later. And after that, you know D1 and D2. And about the distance, they tell you total also. D1 plus D2 is equal to 210 km. So similarly, by your understanding about this part, speed is equal to d divided by t here. So 72 is equal to d1 over t1. I hate fractions, so d1 is equal to 72 t1. This part, S is also equal to d over t. In this case, 90 is equal to d2 divided by t2. So d2 is equal to 90 times t2. We got this component. Now we are going to put it back into our given constraint here. So it's more convenient to use D first, since D1 plus D2 is equal to 210 km. So that means 72 T1 and then plus 90 T2 is equal to 210 km. And after that, we have T1 and T2 relation. So we have this relation. This implies that T2 is equal to 161 minutes. And then minus T1. So 72 T1 and then plus 90 T2, that means 161 minutes minus T1. Now we successfully write down an equation with T1 only as the only unknown, so we can solve it. And don't forget it, the time now is represented in form of minutes. But be careful that T1 we use here is using hour because the unit is over H. So T basically it should be using the unit hour. That's why before we have any calculation, we need to change this in terms of hour first. Then basically this is exactly the same as the simultaneous equation that we have in the previous method. So continue. So how long does it take from P to Q? That means we are interested in T1 only. We don't concern T2. So we can stop calculation. Time span. Don't forget to write down the units here because it's confusing if you don't write down unit. We have both minutes and also hour here. You must tell me you are talking about hours but not minutes.